So in our previous video, we talked about how to create a parametric table. And the idea of a parametric table is that you can, instead of just getting a single solution, you can get a whole bunch of solutions that correspond to varying some independent variable. And for each value of that independent variable, recording the value of a bunch of dependent variables. And this kind of information is most conveniently viewed in the form of a plot. Rather than just a data table. So in this section we'll talk about how to create a very basic sort of XY type two-dimensional plot in order to show the data contained in a parametric table. And we're going to start with the parametric table that we created in the previous video, and that EES code is shown here, and there's a link to that video in the description section. So the outcome of that work was to create this parametric table right here. Right? And this parametric table is named Table 1, and in it we have a dependent variable, which is the magnitude of force F1, which was, if you remember, one of the forces on an eye bolt. And the outcome, the dependent variables that we recorded were the angle of the resultant force and the magnitude of the resultant force, which are in these two comments right here. So if I want to create a plot from these data right here, what I would do is go to the plots menu and hit new plot window. You can see there's a bunch of different plot options here. We're going to stick with the simplest one, the top one here, which is XY plot. And that brings up this new plot setup window. And in the new plot setup window, you got a bunch of things you can do here, but the main thing you want to do is specify what data do you want to plot. So over here you can specify which table contains the data, and we don't have many options here. We have one parametric table, so that's kind of the only place we can go to get data. And then over here, these are all of the columns in that parametric table, right? So what do you want on the x-axis? What is the independent variable? And for us, the independent variable is the magnitude of force 1. And then what do you want on the y-axis? And so let's go ahead and put the magnitude of the resultant force on the y-axis. And if I hit OK now, you can see that I get a plot showing the magnitude of the resultant force as a function of the magnitude of the applied force, number 1. So almost every aspect of this plot can be modified in order to customize or improve it. So one of the things we're probably going to want to improve right away are these axis labels. So if I just double click on one of these labels, I can bring up this dialog that lets me turn this into something more descriptive. So maybe the magnitude of the resultant force, and that's in pounds force. And yeah, let's go ahead and center that. And this magnitude of force 1 also in pounds force. So that's better for sure, right? The other thing I can do is adjust the scale if I decide I want to adjust the scale. So you do that by double clicking or right clicking on any of these scales. So let's double click on this scale, the Y scale, and that brings up this. You can change all different kinds of things about it, including the range and the interval. So the range and the interval seem okay here. Maybe you want some grid lines, some ticks. That probably is better. And then here, let's do the same thing for this scale. Add some grid lines. The range seems okay, and we'll leave that alone. So that's a much better version of this plot. Alright, so if I want to copy this plot and paste it into some report that I'm writing or something like that, you could take a screenshot of it, but that's not a very good way to do it. Instead, I think what I would want to do is copy this as either a bitmap or an EMF. So if you go to options and then look at preferences, one of the tabs here is plots. And right here is where you will specify how do you want to copy a plot. So you can copy it as a picture, which is an EMF file, or a bitmap, or the default is both. You can change the resolution. You can copy it in color or not. I'm going to stick with both here. And if I go here now and just hit Control C, I've now copied the plot, put it on the clipboard, And if I open up, well, any word processing software, I'm just going to open up Word because I think a lot of people use that. Blank document. And now I paste into Word, so let's go ahead and paste special. You can see I have the option of either a bitmap or an EMF file. Let's go ahead and hit bitmap, I guess. And that's a high resolution now. If there were color, it would be in color, a bitmap of that plot, which is a nice way to put that into a report or something like that. All right. So what else do we want to talk about plots? A lot of times you might want to make multiple plots or plot multiple data series on one plot, I guess is a better way of saying it. So for example, let's see, this is the magnitude of the resultant force as a function of the magnitude of force 1 with the other two forces that are applied to the eyebolt set to be fixed values. So force 2 has a magnitude of 500 and force 3 has a magnitude of 800. If I want to, I could also plot on this the same dependent variable as a function of the independent variable for a different value of, let's say, F2's magnitude. So maybe I want to turn this to 600 pounds force. All right, and now I'm going to run my parametric table again. So calculate, solve table. And now these data in the table are different. They've changed because I have a different, different problem once I change this number. So if I want to now, I can overlay this set of data onto this plot, right? So what I would do then is go to plots. I don't want to make a new plot, right? That would just make a whole new plot. Instead, I want to overlay onto the existing plot that's in front here. So I'll hit overlay plot. Yeah, that's still the independent variable. Here's my dependent variable, and I hit OK. And now you can see I have two data series. The bottom one is for 500 pounds force for F2, and the top one is for 600 pounds force for F2. So one thing maybe I want to do is extend the scale. If I hit automatic scaling, it will automatically adjust the scale to encompass all the data, so that's pretty convenient. And the other thing I want to do whenever I have multiple data series on the same plot is label them, right? So I do that with this add text option from the toolbar. So here's my plot toolbar. If you happen to get into a situation where the toolbar doesn't exist, like I did right here, you would go to plots and you would go to show toolbar, and it brings it right back again. So there's your plot toolbar. So let's add some text. Let's see, 500 pounds force is the bottom one. If I want to, I can add a legend symbol right here. I think I would rather not do that and just put that right here on top of that data series. And then 600 pounds force is the top one. Now let's throw that one right on top of this data series like that. So now I have a nice plot showing what happens as a function of the magnitude of force 1 for various values of the magnitude of force 2, which is potentially handy. All right, you can modify how the data series are plotted. So if you just double click anywhere in the plot itself, you get this modify plot window, and this top box will show you all the data series. So here I have two data series. The top one is the first one I plotted, that's 500 pounds force. If I want to change how that's plotted, so maybe I don't like that this is a thin line, I want it to be a solid red line, that's easy to do. And the bottom, maybe I'd like this to not have symbols and be a little bit thicker, but blue, and that's okay. And you can see that I changed those characteristics. So you can change pretty much anything you want on these plots. One thing that's kind of nice, so let's go back here and let's get rid of this second plot, which means we probably ought to get rid of these two things. And now instead of overlaying another independent variable that has basically the same scale as the first one, right? So here I plotted two different magnitudes. Let's, on the same plot, plot the angle of the resultant force. So let's go back to 500, and we'll run our parametric table again. So now this is the magnitude and this is the angle. So I might want to plot these two things on the same plot. And I do that the same way. So overlay plot, magnitude, here's angle. I guess we can leave all that stuff alone and hit OK. And what you see now is that because the magnitude and the angle have such different orders of magnitude, the plot becomes a lot harder to read, right? So in this case, this is a situation where it might be nice to have multiple y scales, right? So if I double click this, you can see that down here I have the option of having this plotted on the primary y-axis, which is y1, so that's the left y-axis. Or if I want to, I can plot the angle here on the secondary y-axis, which is y2, which is that one right there. So let's go ahead and hit that. And what it's done now is it's moved these data to be plotted over here, right, which makes it a lot more readable, right? Probably I want to change this, so angle of resultant force, I think this is in degrees. And I might want to label these two things so I know which axis they refer to, so I can use my line tool and go like that, and we will give it an arrow so I know this is now the magnitude of R. That's probably a little bigger than I really want. Oops. So let's make it maybe 30. It might be a little small, but that's okay. And then this other data series, this is the angle of R. And I will want that to point over here to this. So that's the nice plot now, right? I plotted two data series on two different axes, and that looks pretty good. All right, one last option that's really handy here is I can have this plot automatically update as the data in this parametric table change, right? So, you know, this is for a specific set of conditions. Maybe I want to know how the angle and the magnitude change if I change these conditions. And so that's the automatic update option. So let's go ahead and go back here. And for each of these data series, I'm going to have, so let's see the top one, I'm going to have it automatically update. And I'm going to do the same thing here for the bottom. I'm going to have it automatically update. And I'll hit OK. And now, anytime I change the data in the table, the plot itself should automatically update. So let's go back here and maybe change this to 300. And we'll solve our table. So the table solved. And if I go back here, what you should see is these data changed as well. And you can tell that they changed because I gotta get back my toolbar, because these markers moved a little bit as well. But this is now the angle and the magnitude of the resultant force for F2's magnitude having changed to 300. So this is a nice way to look at things as, you know, parameters in your problem change. You can have kind of a real-time view of how that changes the data that you're calculating. Yeah, I think that's enough for the basics of how to make a plot. Hopefully this will get you started making some nice sort of professional looking plots that show the data from your EES calculations.